Function notation is used to represent the point xy as the point x comma f of x. Other letters besides f may be used in order to identify multiple functions by different letters. Okay? Have you guys seen this before? The correct answer is to nod your head or say yes. You have seen it before. Okay? But clearly some of you don't remember it. Okay? So if f of x equals 2x plus 3, we want to find f of 4. We want to find f of negative 1. Okay? Well, what used to be right there where the 4 is? An x. That means anywhere there used to be an x, I want to put a 4. This used to be a 4, an x, and I want it to be a 4. Anywhere else there was an x, like right beside the 2, I want to put a 4 as well. What is 2 times 4? 8 plus 3? So f of 4 is 11. So the ordered pair is 4, 11. Remember, it looks like x and f of x. Okay? X comma y is how we've always said it, right? But in function notation, this is what it looks like. All right? What if we're trying to find f of negative 1? Anywhere there was an x, we're going to put a negative 1. Good. Negative 1 here, negative 1 here. What is 2 times negative 1? Negative 2, good. Plus 3? 1. So f of negative 1 is 1. What's the ordered pair look like? Negative 1, 1. Okay? So we have some little practice problems right here. Given that g of x equals x squared plus 2 and h of x equals 4x plus 10, evaluate the following. So let's pretend for just a second I said to you that this was y equals this and y equals this, and I said find the value of the function when y equals 3. Which one would you use? Yeah, I don't know either, right? It would be a big guessing game, right? And of course, if you guessed one thing, that's not what I would have wanted, right? Okay? So tell me one benefit right now of using function notation. We know which one we're talking about, right? I can be very specific about which function I'm talking about. What if I said, I think we even already had this discussion, what if I said, boy, get the door? Who am I talking to? But what if I said, Tanner, get the door? Would you know who I'm talking to? Okay, it's the same kind of way here. We don't just call all these y's when we're talking about function notation. We can call this one up here f, this one down here g of x, and this one h of x. So we know exactly which one we're talking about. Okay, so if we're trying to find h of 3, I'm clearly going to use h of x, right? But I'm going to find h of 3, and that's going to equal, I'm going to rewrite the function, but instead of writing x, I am writing 3. Good. 4 times 3 plus 10. H of 3 equals 22, because 4 times 3 is 12. 12 plus 10 is 22. What's my point? I mean the coordinate point. 3, 22. Yes? Okay. G of negative 3. Once again, I know exactly which function I'm talking about because it says G, right? Not like gangsta G. I can't even say it with a straight face. Okay, sorry about that. I'm talking about just the letter G, okay? So we have G of negative 3 equals negative 3 squared plus 2. Now, we're about to have a conversation that I'm probably going to end up having with you about 526,304 more times. Okay? I would just as soon be able to say it like 1 or 2 more times because we remember it. But somebody's going to forget. Can you guys be the class that doesn't forget? Okay. Tell me, what is negative 3 squared? What is negative 3 times negative 3? 9. We're all clear about that, right? But if I punch into the calculator negative 3 squared, enter, it's going to tell me the answer is negative 9. Because the calculator follows order of operations, which means I square it first and then multiply by negative. Is that what I meant? No, I meant negative 3 squared. I have a couple options here. Okay, I can write the parentheses, I can put the parentheses in the calculator, or I can be smart. I can know that if I say a negative times a negative is going to be a positive number, and just, hopefully we're not having to put in our calculator 3 squared, right? But what if we have like 74? Do you know 74 squared? I don't either without a little bit of work, right? So if I know it's a negative 74 squared, can I just put 74 squared in the calculator? Isn't that going to give me the same answer? But if I do put in negative 74 squared, I've got to put parentheses around the negative 74. Fair enough? Okay, so what is negative 3 squared again? 9 plus 2? So g of negative 3 is 11. So my ordered pair is negative 3, 11. G of a plus 1. Yeah, some of you just looked at me like, what? What used to be there? An x, right? So anywhere there's an x, what do I put instead? A plus 1, right? So I'm using g, so I say g of a plus 1 equals a plus 1 squared plus 2. What does a plus 1 squared mean? Do you? What does it mean for something to be squared? Multiply by itself. So doesn't that really mean a plus 1 times a plus 1? Don't I distribute here and get a squared plus 1a, and then distribute here and get 1a plus 1? Guys, if all you do is distribute the squared into each term, you're going to get it wrong every time. Please don't do that. Okay? I have common term right there, so I have a squared plus 2a plus 1. But when I go to write my final answer, what do I have to take care of as well? The 2, right? So my g of a plus 1 is actually going to equal what? A squared plus 2a plus 3. Right, because we have this 1 right here and we have this 2 right here. Excellent. Good catch. Okay, any questions? Why didn't I ask you to write it as an ordered pair this time? Could I write it as an ordered pair? Yes. Would it do me any good? Would it help me in any way? No, it would just be a big mess of gobbledygook. Okay? In function notation, f of x, which symbol represents the domain? X, right? Which symbol represents the range? Y. Traditionally, it's the y that represents... I don't know why I wrote y, sorry, because I was saying y. Traditionally, it's the y that represents the domain, but in function notation, it's f of x. That's the same thing as that, right? F of x, so that represents the range. Okay? What are the benefits of using function notation? Well, we just said them, didn't we? What are they? Or what's one? What? Faster. What's another one? What's the important one I told you? Yeah, to keep track of what we're talking about, right? Keep track of which function we are talking about. We good? What do you mean by faster? You think it takes us time? Okay, I'm okay with that. Yeah. Okay, look at number 4. We ready to go on number 4? We good? Label the axes, the origin, and the quadrants in the coordinate plane below, and then graph the points in the set. Okay, label the axes. Oh look, they already are. X, Y. Label the origin. 0, 0. Label the quadrants. 1, 2, 3, 4. Why do we write them as Roman numerals? Because, right? Because we're cool. Absolutely. Good. Good. Okay. And because we already have a whole bunch of other numbers, we don't want to confuse ourselves. Okay. Plot the points. -2, 5. 3, 4. -3, -5. Right there. 0, 4. 1, 0. 4, 5. And 0, -2. I would like to start with letter D. Because if we know the answer to letter D, that makes A and B a whole lot easier on us. Because we know how to approach A and B. Okay? So let's have a discussion. Is it continuous or is it discrete? Okay, I've heard most people say discrete. I can make a Y out of that. I can take a pencil and draw a Y on that, can't you? Or are you just not being creative? Does discrete or continuous have anything to do with being creative? No. What does it have to do with? If you can have points in between, can I have points in between? It gave me a list of points. I can only go with the list of points it gave me. So is this continuous or is it discrete? Discrete, very good. What about this thing? Explain your reasoning. It gave us a list of points. Okay, so now we can approach the domain and range the way we need to, right? What's the domain? Oh, to be clear, when we talk about domain, we're going to use the letter D to represent domain because it starts with a D. Okay, just checking. What's my domain? Wait, what are you telling me? Oh, all the x's? Do I just write down all the x's of the coordinates I was given? Absolutely. What do you mean in order? Like in the order they were given to me? Oh, least to greatest. Excellent. Pretty bracket thinger. I know that's not technical, just go with me. What's first? -3? -2, good. Then 0. Uh-oh. There's 2 of them. You just write it down once, don't you? Okay, do you know why? That's what you were taught. I'm glad that's what you were taught because it's correct. I'd like you to know why. Why do we use function notation? Because it's faster. Do we need to write both of them down? It's not necessary. It's repetitive. Okay? So -3, -2, 0, 1, 3, 4. Done. Another pretty bracket. Pretend mine are pretty. Just get over it. Questions about the domain? Absolutely not. Excellent. Okay. Range. Wait. What letter are we going to use for range? Oh my gosh. R. You guys are so brilliant. What's my range? Do we do it the same way? But it's the y's this time, right? In the order it was given to us? Least to greatest, right? Okay, so in this particular case, -5 is first, right? Is it first because -3 is first and that's the point that goes with -5? No, it's just least to greatest. It just happens to be that way, right? Okay, then what? -2, 0, 4 and 5? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. If I didn't put the second 0 up here, that would be 7 and 5. Is that allowed? Absolutely, because why? How many 4s were there of the range? 2. How many 5s were there in the range? 2. It's okay. All right? Is it a function? It's a relation because it gives it to me all together. I know the points are related somehow. I don't have to know how. But is it a function? 2 things I need you to know. First of all, does it pass the vertical line test? If I slide my marker across the page, is there any point that it touches 2 points at one time? Right there, right? Right along the y-axis, isn't it touching 2 points? It's not a function. Okay, so first of all, is it a function? No. Okay, so reason number 1. We're going to write 2 reasons here right now for today. From now on, when we're asked this question and asked for a reason, we'll choose which reason best fits the situation. But I need you to understand that they're the same thing, just using different words. Okay? So number 1, it doesn't pass vertical line test. So what if I don't have a graph to look at and all I'm given is a list of points? How can I tell if it's a function or not? So I'm hearing a lot of good things, but not quite exactly the phrase that I need. So can I just tell you, is that okay? It is not a function because x's repeat. Do you notice that there's x's that repeated? In fact, it's the 0, right? You asked me if we needed to write it multiple times. If that happens, it's not a function. Okay? Questions? Number 5. So which question do we want to answer first? Probably the 4th one, right? Is it continuous or is it discrete? And for the record, we're going to talk about A and B at the same time. Continuous and discrete. Are they both continuous? Are they both discrete? Is one continuous and one discrete? Why do you think this one is continuous? That's what I was afraid you would say. I was afraid you would say because it has an arrow. Okay? Let me show you something real fast. That has an arrow. It's a discrete function. Because there's a hole in it. Okay? Well, it is right here. That's what I'm saying. I don't want you to just say, oh, look, there's an arrow. It's continuous. The arrow tells you it is continuing, and that's 2 different words. It's 2 different words. Okay? Continuous means what? It has points in between, and I can draw it without picking up my pencil. Okay? So, what do you think? Can I draw this without picking up my pencil? Then it is continuous. Can I draw this without picking up my pencil? Yes, it is also continuous. Yes, ma'am. But where is the hole on A? At the end or at the beginning? So it's a stopping place or a starting place. Okay? So now I know that it's continuous. I know how I can write the domain and range, right? Yeah, sorry, what? Nope. What's the domain of this function? Another way to think about domain is, what are the x values? And even a simpler way to think about it is, how far to the left does it go? How far this way does it go? -2, right? and x is greater than negative 2. If we start to the left, we say, how far left does it go? Negative 2. As I'm continuing right, how far to the right does it go? To 4, right? So somebody please tell me why my signs are different. Why is this one a less than, and why is this one a less than or equal to? Because of the open circle, right? Is negative 2 part of my domain? No. It has an open circle. It's not part of it, but that's where it starts. It starts there, but negative 2 doesn't work for whatever reason. But I say everything greater than negative 2, not including negative 2, but everything greater than negative 2, and then everything less than or equal to 4, because that one's colored in, isn't it? We good? D. What about my range? How far down does it go? Negative 4? Less than or equal to? Because it's colored in, right? And that's a Y, because we're talking about range. Is less than or equal to what? How high does it go? 3. So I need to show you something on a side note. Okay? If you're planning on taking the SAT or ACT, or if you're planning on go to college, you need to know that there's a different way to write domain and range. It's not dramatically different, but it's slightly different. And I need you to have seen it before you get there. Okay? The other way to write it is like this. Starts at negative 2, but does not include negative 2. And goes all the way to 4, but it does include 4. The range starts at negative 4 and includes negative 4, and goes all the way to 3 and includes 3. This is a parenthesis and this is a bracket. A bracket. There could be, see, like this one has both brackets, but this one has both brackets because both of these numbers are included as part. Colored in circle, colored in circle. Tell me what to draw. Like that? Oh, is that how you guys do it? Yeah. Okay. So she's showing me what they do. Okay. They, on a situation like this, the negative 2, 4, they do this. Negative 2, 4. They have the bracket still, but it faces the other way to say that negative 2 is not included. Okay. For the record, that doesn't show up here in the United States. Okay. All right. Not that I know of anyway. I haven't seen it anywhere on any study materials, and I haven't seen it in my master's classes. Okay? It very well may show up, so we might as well know about it, right? Okay? We're going to use not this, but that instead. Does that make sense to everyone? Thank you for showing me that. I appreciate knowing about that. I didn't know about that before. Okay? Hey, if you want to use that on your paper, use it on your paper, because that's how you know it. I'm totally okay with that. Okay? All right, so is this a function? It doesn't ask for a reason, but can you tell me why it is? It does pass the vertical line test, doesn't it? Okay. On what intervals is it increasing? Yes, ma'am. Oh, yes, function. Okay, don't confuse yourself. I mean, I have enough of a job doing that myself for you, so don't you do my job. Okay, I see what you're saying. Do you see that these are the two places that it is increasing? Okay, so I have to figure out how to write those intervals. Right? So it's going from negative 2 to 0, because we're only talking about x's. When we talk about intervals, we're only talking about domain values. Okay? So from negative 2 to 0 is increasing. Do you agree with that? So from -2, whoops, to 0. Does that make sense? Then tell me what the other interval is that it's increasing on. This colored in part? 2 to 4, right? 2 to 4. So this can get confusing sometimes, and I don't want you to let it. But we need to have a conversation about this. Okay? Because if you look at the answer key, that's the answer. -2 is less than x is less than 0. And it doesn't include 0. And it's right. Is this point increasing? Can an end point be increasing or decreasing? Or is that just the stopping place? It's the stopping place, isn't it? It's where it changes a direction or where it just completely stops. So we can't not include the endpoints when we're talking about increasing or decreasing. Does that make sense? Okay? So then tell me, please, where is it decreasing? Be brave. From 0 to 2. How am I going to write that? 0 is less than, x is less than 2. Now, if you accidentally write the less than or equal to on your test, I'll probably just like put a small frowny face. Not even like really frowny, just like a straight line. But I'm not going to take points off for that because we're not focusing on that right now. We will later on maybe, and we'll focus on it. Then we'll take points off then, but not yet. Okay? Learn it now if you want to. That's great. But we'll worry about that later. Okay? Second part. What's the domain? How far to the left does it go? To 0. How far to the right does it go? To infinity, right? So we have to know how to write this two ways. So the first way that we're going to write our domain is x is greater than or equal to 0. Isn't that what you told me? It starts at 0 and goes all the way? Okay? How am I going to write it if it looks like this? I start at 0 and go where? Infinity. Bracket or parenthesis? Bracket means it includes the end of that point. Do you know where the end of infinity is? Me neither. Parenthesis. Okay? Anytime you use an infinity symbol, it's going to be a parenthesis. Okay? What about the range? How far down does it go? 0 to infinity. So this time it's y is greater than or equal to 0. But this is going to look the same, isn't it? Is it a function? Yes. It does pass the vertical line test. Excellent. Where is it increasing? X is greater than or equal to 0, or sorry, greater than 0, right? It's increasing everything greater than 0. Where is it decreasing? Never! You could just write it's not if you want. Okay, we have two things to do in 4 minutes. Oh, we have 6 minutes. We're good. Ready? It gives us this information, so complete the table. What is -3 minus 1? -4. What is the absolute value of -4? So I heard somebody say 4. Why did you say that? Okay, you know how I feel about that, right? Just because that's how you were always taught, I would rather you know why. Fair enough? So can I tell you real quick why? Why do we just say, quote unquote, take off the negative? Which I don't like, but we'll get there later. Okay? We said that negative 3 minus 1 is negative 4, right? The absolute value of negative 4 is the distance it is from 0. How far is negative 4 from 0? 4 away. Okay? We already had a conversation about negatives and distance anyways, didn't we? Can we have negative distance? Most of the time, no, right? And especially not in this situation. So that's a 4. What's 4 times 2? 8. What is negative 2 minus 1? Negative 3. What is the distance from 0 of negative 3? 3 times 2. 6. What's negative 1 minus 1? Negative 2. What's the absolute value of negative 2? The distance from 0. 2 times 2? 4. What's 0 minus 1? Negative 1. Absolute value of negative 1? 1 times 2. 2. What's 1 minus 1? 0. What's the distance from 0 of 0? 0 times 2. 0. 2 minus 1? 1. Absolute value of 1? The distance from 0 of 1 is 1 times 2. 2. 3 minus 1. 2. Absolute value of 2. 2 times 2. 4. So plot these points. Negative 3, 8. Negative 2, 6. Negative 1, 4. 0, 2. 1, 0. 2, 2. 3, 4. So I have a left-handed person's check mark, right? Is that really what I have? What do I have? So here's the better question. Is this discrete or continuous? Well, one of those is right, isn't it? It's either discrete or continuous. Did they give us points? What did they give us? They gave us an equation. We picked up the points so we could plot something on a graph, but since they gave us an equation, is it continuous or discrete? It is continuous. So can we connect these points? Should we connect these points? Yes. Oh, and now it's not a check anymore, is it? It's a V, isn't it? Okay. So we already answered this one, continuous. What's the domain? How far to the left does it go? Pardon? How far to the left does it go? How far to the right does it go? So I have a couple choices. I can write this fancy R, which means all real numbers, good. Or I can write it the other way, which looks like this. Now, some of you are scoffing at me because I just wrote a negative infinity. Is there such thing as negative infinity? No, it's just infinity, right? But why did I write a negative infinity? Because I'm stupid? That's not nice to say. Why do we write negative infinity? Because it's to the left. Very good. Because it's to the left. Okay? So what's my range? How far down does it go? 0. How far up does it go? So y is greater than or equal to 0, or from 0 to infinity. Yes? Is it a function? Yes. What's the the best parent function that represents this data? Say it. Absolute value. Oh my gosh, how many times did we say that up here? Right? When we were doing the table? All right, can we do this? We have 2 minutes. -2 plus 1. -1. What's the square root of -1? You don't know yet. Not yet. But right now you don't know. -1 plus 1. 0. What times itself equals 0? 0 plus, times 2? 0. 0 plus 1. 1. What times itself is 1? Isn't that the square root of it? 1 times 2. 2. 3 plus 1. 4, square root of 4. 2 times 2. 4. 8 plus 1. 9, square root of 9. 3 times 2. 6. 15 plus 1. 16, square root of 16. 4 times 2 is 8. Yes, you were just there early. It's okay. Plotting these points. What do I plot at -2? I can't plot anything, can I? There's an error. I can go to -2, but I can't go up or down any. So -1 is 0. 0 is 2. 3 is 4. 8 is 6. And 15 is 8. Oh, can I connect these? I almost connected them without asking. Why can I connect them? They gave us an equation, so it is continuous, so I can connect them. I'm going to keep going and finish this. If you need help, watch the video. I'll have it on my blog. Okay? I need domain and range. Domain, how far to the left do I go? I go all the way to -1. How far to the right do I go? To infinity. So I can say x is greater than or equal to -1. The other way I would write this is -1 to infinity. Okay? The range, how far down do I go? I go to 0. How far up do I go? To infinity. So y is greater than or equal to 0. This other way, 0 to infinity. Is it a function? Does it pass the vertical line tests? Are any of the x's repeated? It does pass the vertical line tests and none of the x's are repeated, so yes, it is a function. We discussed just a second ago whether it was continuous or discrete. It is continuous because we were given an equation to start with, so that's why we connected our points. And last, what parent function best represents the data? Well, hopefully you see in the equation that there's a square root symbol. When you see that, you know it's going to be a radical parent function, or you can also say square root. Okay? I hope you have a great weekend. I will see you Monday. Peace.